Okay, so we're on 1-1, day 2. So identifying positive and negative intervals. A graph is positive when all points are above the x-axis. So a graph is positive when all points are above the x-axis. So I don't understand the question you just asked me.
Like on the x, when they start at 1, is that point 1?
No. If this is 20,
It's 5.
it's 5. Look at what you have and count back. Okay, so the first thing you're going to do on your paper is you're going to write positive and negative. I really wish my pencil would be working. It looked like a first grader writing. Okay. And you're going to go from right to left and fill those out. Try it on your own. Cooper, are you trying this on your own?
Yes.
Okay, who wants to try the first interval? Emma?
Oh, I was fixing
Who wants to try the first interval?
I got the positive
I just want the first interval. I just want a interval. Give me one.
interval. Oh, that was.
One group of parentheses. Emma.
Oh.
negative infinity, negative 5.
Negative infinity, negative 5. Is it what? Positive or negative?
Negative.
Okay. From negative infinity to negative 5. So Emma says for the x values from negative infinity to negative 5, the y values are negative. Is that true?
Yeah.
Yes. Okay, who wants to try the next piece? Brandon?
Not really. I got it.
Well, if this one ends at negative 5, where's the next one start? Negative 5. I'll let you do the next one. So we have to do negative 5. So at negative 5, it switches from negative to what? Positive. So you come up here and say negative 5
What also stop?
to what? Yeah.
You.
Negative 5 to 5. For the x values from negative 5 to 5, the graph is positive. The y's are positive. They're above the x-axis. Okay, Alex, where's the next interval start?
Well, this week I didn't get that far.
Okay, so you're going to do it right now. Alex, it ended at 5, so the next one starts at what?
5.
5. Okay, so at 5, this graph was above the x-axis. Now it is where? Below, which is that positive or negative?
Negative.
So at negative 5, sorry. Oops, what'd I forget in between my two? The intersection. Not the intersection, in the union. Of 5 to what?
Negative infinity.
Not negative infinity. X values are going x. These are x's. The x's go this way. So positive infinity. So we are writing the x's that describe the y's. This is positive y's. This is negative y's.
Oh. Alright.
Okay? Yes?
How do you pick the 5, 5? Like the negative 5 and 5?
You're just looking at the graph. Because this graph, it tells me that this line right here is 20. So that has to be 5, 10, 15, 20.
No, I meant like negative 5, 5. I know how you got it. I just.
Okay, because this point right here is negative 5,
Uh-huh.
and this point is 5. And for those x values between 5 and negative 5, my y values are positive. That's how I got it. Other questions?
No.
Okay,
No.
so now we're going to move on to increasing and decreasing. So, a function is increasing. Back. Okay, a function is increasing when its y values are increasing from left to right. And it is decreasing when the y values are decreasing from left to right. So y values, when I look at a graph from left to right, looking down here, and I go like this. Okay? So what are the values doing? They're here and they're going what? What are they doing? Increasing. Yes? And then right at this, what would you call this thing of this graph right here? What would you call that right there? The peak? Okay, it is a peak. You need a math word for it? Would it be the maximum?
The climax.
The maximum. And we're math. Okay, so it's maximum. And if this was reflected the other way, it wouldn't be a maximum anymore. It would be a what? Minimum. So it increases to the maximum, and then it does what? Well, or decreases to whatever, right? We will eventually have graphs next year. We will call them relative min and max because the graph does more stuff. Right now, your graphs aren't doing very much stuff. Okay, so a function is increasing if the y values are increasing from left to right. It's decreasing if they're decreasing. That's it. Look at the graph. Are we going up or down? But it is always from what direction to what direction? Left to right. That's why when we did the intervals of positive and negative, I went from what direction? Left to right. We do everything left to right on a graph. Okay, so here's our example. Are we done writing our definitions?
No.
You guys need to be quicker. You'll quick. Need to get a metronome so you know how quick you should be writing. You'll get there. Okay, so I have a table. Yes?
Yes.
So increasing, decreasing changes at a maximum or minimum. We've established that already, right? When I did, I'm going to go back real quick. When I did, go back. Not what was supposed to happen. Okay, when I was here on this slide and we did positive and negatives, it changed at what were these things? What's this thing and what's this thing? What are they? All of the graph.
Points.
Yeah, they are points. What is its name on the graph? X-intercepts. Okay, positive and negatives changed at the x-intercept, right? Because that's where you hit the x-axis, and y values are positive above it, and they're negative below it, correct? But when we are doing, let's see what's going to happen here. When we are doing increasing and decreasing, they change at maximums or minimums. See that?
Yeah.
So when we look at just a table, this is just a table, right? We're looking for a max min where it changes. So I'm looking at my y's, and what's happening when I look at this table? I have -1, 0, 1, 2, 1, 0, -1. Where does something happen at?
0.
-1, 0, 1, 2, 1, 0, -1.
Oh, the 1.
Where where does it change?
X intercept.
No.
Because it goes from -1 to 0 to 2.
It goes
Then back
it
down to
goes
1.
at 2 is my maximum, isn't it?
Right.
So is 2 going to be my breaking point where something's happening?
Yes.
Yes. So we write INC for what? Increasing, and DEC for decreasing.
Incorporating.
And we start at negative infinity if we have arrows. If we don't have arrows, sometimes it's just a picture, so it could have an actual value. But these have arrows, right?
Yeah.
So we start at negative infinity, and where are my y values doing? Are they increasing or decreasing? As I come from negative infinity on my x's, what are my y values doing?
Decreasing.
-1, 0, 1 is decreasing. -1,
No, they're
0, they're increasing. So from negative infinity to, and I covered it up because it actually goes to 2, right?
Oh.
So I want my x value. What's my x value at the maximum y? Alex?
3.
What is the x value at the maximum y?
Oh, 2.
That is the y value. What is the x value?
7.
This is the y. What is the x?
Oh, 0.
Okay. Then what happens to my y's as I keep going down? They decrease. I'm down the chart, but up my x values, yes?
Yes.
So at 0, I go, and my y's are decreasing. And when do they stop decreasing? When do they stop decreasing?
Infinity.
Okay, we're going to try this over again.
But
No. I'm not even, I'm really getting frustrated. Alex or Cooper, one of the two of you move. I want one of you at this table now. Your talking is distracting. And it's distracting you and everyone else in the room. Don't sit together tomorrow. Whoever is moving, sit where you move. Okay, so I keep pointing at the graph and I need not to point to the graph. We're only going to look at the table. We're going to try this a different way. What is my smallest x on this table? -3. Okay, as my x's are going -3, -2, -1, 0. They are going up, correct?
yeah.
As my x's are increasing, what are the y's doing? -1, 0,
They're increasing
1,
too.
2. They are also increasing. Yes? So this table, the smallest x value is -3. Correct? So I start at -3. Now, at what x do my y's peak? 2. So right here is my transition point from increasing to what? Decreasing. So that x value is what? 0. So it's on the increasing, and then it also goes on the what? Decreasing. But these are parentheses, so they're not included on either one. The 0 isn't included, is it? Because at 0, 2, is this graph doing absolutely anything?
No.
No, it's just sitting there at a point. Now, when I leave 0, what are my x's still doing? What are my x's still? They're still increasing, but what are my y's doing now? Decreasing. Okay, so they decrease until what is the smallest value on my table? X. X. Not -3. Well, I mean, I get where you said -3. The last value is 3. Does that make more sense?
Yes.
You need to stop just puking out information because it's not helping anybody. Okay? Ask a question if you're not understanding. So now we're going to look at the chart. the graph. Emma, you have a question?
No.
Okay, so we're going to look at this chart, or this graph. So I have increasing, and I have decreasing. Again, we are writing the X's for when the Y's are doing something. Got me? So, what is the smallest X that is portrayed by this graph? There's an arrow here, so that means this graph goes on forever and ever and ever. Yes? So we need to start at negative infinity. Correct? So, negative infinity somewhere down here. I jump on the graph. Jumping on the graph right here. It's going to go, what are my Y values doing? Increasing to here. So it was negative infinity.
2.
No. What values do I write down?
Y value.
No.
No, X value.
X values.
Is this a new included, or are we adding on to our old one?
No. This is not, this is new.
Okay.
This is the second example. The intervals only have what values in them? These are X's, and increasing, decreasing are Y's. So, X is negative infinity. It's out here. And as I come this way, my Y's are increasing until I get to what X? What X? What X is right there?
0.
0. You keep saying your Y's. Okay, so I'm at 0 now, and my graph, my Y values are going what? Down. For how long? Infinity. So 0 to positive infinity. Intervals are X values. Write it on your paper. Write it in your brain. Increasing, decreasing are what values? The Y values. Intervals are X's. You're telling the X where the Y's are doing something. The Y values are increasing from negative infinity to positive, or to negative infinity to 0 on the X-axis. The Y's are decreasing from 0 to positive infinity on the what axis? X. Intervals are what values? X. Increasing and decreasing are the what? Y.
So GX is Y.
G of X is Y. It's function notation.
Okay.
Am I good?
Yep.
Okay. Average rate of change. Okay, this is in function notation. She just asked me G of X is Y. Yes. F of X, G of X, I of X, K of X, L of X. It's the output. It's the Y's. It's function notation. So average rate of change is the ratio F of B minus F of A over B minus A, which is the same as what?
Slope through the line.
Slope. What is the slope formula? Nope. Think we've done it like Y minus Y over X minus X. And there's a 1 and there's a 2, right? Or there's a 2 and there's a 1. It doesn't matter, does it? These two things are the what? They're the same. All this says right here is I plugged in B to the problem and got F of B. Well, isn't that how you get a Y? You plug in an X, you get out a Y? Same exact thing. Average rate of change and slope, are they any different? No. Day 2, we did Jeopardy and I ask you what was the slope formula. And since that day, you keep telling me y equals mx plus b, and I keep saying no. Do you think you need to know the slope formula? Yes. Calculus reviewed it yesterday. It will not ever go away. So make it a goal when somebody says, what is slope? You say y minus y over x minus x. Y equals mx plus b is what? What is that?
The Pythagorean.
No.
Value graph.
Well, it's slope intercept form of a line, correct? It's not the slope. So what that means is, you see this graph? You don't need the graph on your paper. Do you see it? What if I what is drawn between the points? What? A triangle, yes? Okay. So I could use Pythagorean theorem to find the distance, couldn't I? Yep. Okay, we will, but not today. But I could, yes? So if I plug in an A, I get out f of A. I plug in an A, get out a y, correct? I plug in B, which here's is B, to a function, and I get out f of B, so there would be a point right here, wouldn't it? And can I draw an imaginary line between the two and find its slope? Yes. Is it the actual slope of that red line? Slope is changed, like how quickly something is changing, right? Does this blue line match the red line? No, it doesn't lie on it, does it?
No.
That is why it's called what? Average. Because we have 2 points, and I'm just getting an approximate slope, like the change that happened. What do you think happens if I would move these points closer and closer and closer together? Would I get a better approximation of the change? Yeah. And we will start doing that later on this year, and then in pre-calc we do it a lot. And then in calculus you actually get a function that will give you the slope at any point on this graph. So that's what it works towards. Calculus, guys, is how to figure out a slope function of a function. Sorry. So does slope ever go away?
Sadly,
No, never.
It's like
Okay.
toxic X.
So find the average rate of change. So it gives me -2, 0.
Oh, fine.
Okay? And then it says this is the equation of f of x equals 1. So this is an interval. What values are in intervals only? What values are in intervals? X's. So right here, I have 2 x's. I have an x here and an x here. So this is x1 and this is x2. What do I need to find?
Slow. Y.
I think, Gracie, what'd you say?
Is that the Y?
The y's. I got you the x's, yes? So all you have to do is find the what? Y's. If I give you an equation and I give you an x, should you be able to give me a y? Yeah. Okay, so this is the equation, 1. Is there a place to plug in an x? The equation is 1. Is there an x in that? No. So that means that every x, what is the y?
1.
1. So my 2 points are -2, 1, and what? 0, what? 1. So that means, guys, don't put things away till I tell you to. We got time. That tells me 2 minutes, not you pack up. Okay, 1 minus 1 is what? 0. Over -2 minus 0, which is -2. And what is 0 divided by -2?
2. No, you can't divide it by 0.
I didn't divide by 0. 0 divided by -2. 0. I have no candy, and there's 9 of you. How much do y'all get? Nothing. So what is my slope? What is my average rate of change? My arc is what?
0.
0.
Well,
It's 0. So these are what values right here, guys? What are in this bracket?
X.
X's. And you need to find the what?
Y.
Y's. What are in this one? X's. And you need to find the
Y.
Y's. Now, can I just look at this table right here and find my Y's? Yeah. But if I don't have that, I have to plug them in, correct? So at 0, what's my Y? When X is 0, what's my Y?
0.
Negative 1. Tells you right there. When X is 3, what's my Y?
Half.
A half. Then can I do my slope? Yes. You all know how to do the slope function. I'm not worried about that. Okay. These are what in this thing again? X's. So when X is negative 2, what's my Y?
4.
4. Could I plug negative 2 times negative 2 is 4? Could I do that math? Yes. When X is 3, what's my Y?
9.
9. Because 3 times 3 is what? 9. You need to finish the rest of that worksheet. If you don't have it done tomorrow, you're sitting in the hall till you do. Got me? The bottom is for you to think backwards. We're still not doing the book assignment because we haven't got through the worksheet. Got me? Okay. This gets turned in under Monday.
Monday.
This worksheet is still Monday's assignment.